Good evening, Tim.
Hey, how are you?
I'm good. It's 8:30 in the morning for me, and 11:30 in the night for you.
Yep.
The miracle of time zones. What are we going to talk about?
So today we're talking about how Ethereum can solve L2 liquidity fragmentation, because there is a lot of issues with moving between different chains and getting tokens to where you need them to be. And there is a lot of possible solutions in the pipeline. And I wanted to make people aware of that, help them learn about all these solutions.
Cool. And I think, like, even since before you started at Blue Yard last year, you've been digging into this, and so have I. But you've done a much better job. So I'm going to ask you a bunch of dumb questions. So maybe let's go ahead and move forward. And what we're going to look at here is some slides that you put together for a talk that you gave at ETH Prague. But instead of having a presentation here, we're going to have a conversation.
Sounds good.
How should we frame the problem? I think that's where you start, right?
Yes. So this is the core problem. This OX designer is a great follow on Twitter. He puts out lots of designer things, but this is obviously one of the biggest frustrations in Ethereum is that you have money, you have tokens all over the place. You go to an app to use them, and it's like, oh, you don't have the right token. It's not on the right chain. You need to go to some other site and bridge them first, and solve all of these problems that you shouldn't really have to solve. You should be able to come to an app and just use the app.
It's sort of like needing to move data between AWS and Google Cloud in order to use data across the web, right? That's the way I feel. Yeah. So a question for you. You talk about tokens and liquidity. More generally, tokens are, is it right to say this? Tokens on blockchains are basically just data that is assigned to an account, right?
Exactly.
So the problem of liquidity fragmentation is actually data fragmentation more generally. And it could be like if you're, I don't know, playing a game and you want to have portable cross-game assets like a skin that you use in multiple games. If you're playing the game on one L2, then you won't have access to it for a game that's built on another L2.
Exactly.
Yeah.
The big difference between tokens and traditional data is that you can't just copy it to a location to where it needs to go. You have to securely move the tokens, because if you copy the tokens and somehow they end up in two places at once, then we get all kinds of issues. And if somebody can do that, they will maliciously do that, and they'll often that will break the moneyness of that token. Make it not worth anything anymore.
And it sort of defeats the entire purpose of these trustless chains.
Exactly. Yeah. Okay, so the problem is, this is a screenshot from my wallet from a while ago. With Rabby, it shows all the different chains, all the different tokens. The problem is, like, this is a particularly bad wallet. Most of my wallets are a bit better than this, but so you can see I have Ethereum on 4 different chains. I have a whole bunch of just tokens all over the place, and so I have like about $500 here. But if I want to use that $500 in an app, it would be an hour of bridging and swapping and getting everything to the right token in the right place. And so we don't want this. And so we want it to be in a place where you don't notice what chains your tokens are on. I put a little Ethereum symbol in the top corner of each, but really that shouldn't even be there. And when I go to an app, it should just I should just be able to choose what token I want to use with it, and it should just work.
Yeah, this chain switching stuff is one of the worst, or network switching, as it's usually referred to in wallets, as one of the worst UX elements of crypto and Web3, which I think we can all agree already have fairly bad UX across the board. Not 100% of the time, but on average. So yeah, another analogy that I use sometimes when talking about this with people is it's sort of like if you have a computer that has different types of memory and disk that are optimized for different tasks, and in order to use different apps, you have like a pop-up that says, okay, you're going to run this game. It needs to be in faster RAM. Do you want to move it to the faster RAM? Which RAM do you want to move it to? Type in the parameters of the RAM here, and then like find it and search for the parameters. That sounds ridiculous, but actually in the 90s, that's kind of what it was like to use computers, now that I think
of it. Yeah, and now that is a thing of the past. Hopefully this problem will be a thing in the past in 10 years too. So like bridges are getting better. Like so there's this bridge aggregator I use all the time called Bungee. That's what these screenshots are from. And it's useful. It gives you the best rate across many different bridges, gives you the best speed. But oftentimes, like even just using even this better bridge is still like a 6-step process. It takes a while. And the main problem with having lots of bridges is that to actually make them work, people have to lock up liquidity on each side of the bridge. And when they do that, that liquidity can't be used for other things. Those tokens are locked away for a while. And if we have like 1,000 different layer 2s, for all these different bridge combinations between the layer 2s, people have to lock up tokens. And that just won't really scale into the future. We can't have half of the money in crypto just locked in bridges. And so a lot of these solutions focus on solving that as well.
So could you like very briefly explain just how a bridge works in case there's someone watching that doesn't know?
Yeah, sure. Yeah. So for a lot of these bridges, for example, the layer 0 Stargate bridge or the hot bridge are simple-ish designs, and basically a bunch of people lock tokens on either side of the bridge. So some people lock tokens on, say, Arbitrum, and some people on Optimism. And when I want to move my money from Arbitrum to Optimism, I basically take my tokens and I throw them into that pool on Arbitrum. And then a message is sent across the network with a proof that I've thrown my money in this pool and it's now in the Arbitrum pool. And then on the Optimism side, the smart contract on that side gets this proof that I've thrown my money in the pool. And it's like, okay, now you can take some money from the Optimism pool. And then it gives that money to me, takes it out of the Optimism pool and sends that to me.
And these pools are actually just like data structures and smart contracts, right?
Yeah, exactly. Yeah.
So you're putting money into a smart contract and it's locked because you literally can't get to it unless the other side says, okay, now you've released this because you're trying to move it back.
Yeah, exactly.
I see.
And so this works well if you have like small amounts of money. Like if you're moving $100, that's fine. But if you want to move $10 million and there's not that much money in the pool, then like it just can't be done. Or like sometimes it says it can be done, but you lose half your money in the transfer because of slippage. And then there's a second type of bridge that Across and Orbiter and these use. And instead of having these smart contracts that are like pools of money, they have market makers solve the problem for you. So with Across, I still lock my money in a smart contract, but then instead of there being pools of money, someone else, like a solver or a market maker or some person that just has a wallet with a bunch of money, sends me the money I want on the other chain, and then they later go and retrieve my money from the contract. They basically say like, hey, I sent this Tim his money. Let me get Tim's collateral that he put into the smart contract on Arbitrum.
So here's a dumb question for you. Who would be a market maker? Is it literally just some person or entity that wants to make some money through transaction fees? So they get a bunch of cash, turn it into ETH or whatever, and then they play this role and they take some percentage for every transaction.
Yeah, exactly. I think anyone can be a market maker on most of these bridges, but often they're firms that have like a few $1 million on many different chains, and then they'll front that money basically for however long. It's usually only a few minutes, and then they'll charge like a 1% or less fee, depending on market conditions and what tokens you're transferring. They'll charge higher fees for more exotic tokens and so on. And the advantage of the market makers is that you can get money a lot quicker. So I've gone forward these 2 slides. This is something I did on a little bit ago. I was sending money across the Across bridge, and it only actually took 4 seconds to happen. And the reason for that is that a market maker saw my transaction on Base to send the funds, and then they assumed like Base, this transaction is going to be processed eventually and settled to Ethereum. And so they just sent me the money straight away to be the fastest to get the money to me, so then they can take that cut. And then they take the risk of if my money on Base gets reorged or doesn't eventually settle, they take that loss risk. But it's because they did the math and they figured out, well, there's only a very small chance of loss. It's okay for me to do that. And so that with this market makers system, you can make bridges a lot faster than doing the whole smart contract blocking and unlocking on the side.
Cool, thank you.
And so like wallets do want to solve this problem of making your tokens flow automatically to an app, but they because of these bridging issues, because of a little bit of slippage, because it's like takes a lot of time, there's often routing issues and stuff like that. They can't quite solve the problem yet. We need to kind of fix the infrastructure first, and then wallets can make this whole experience a lot better. Yeah. And then, as I was saying before, bridges are getting a lot better, but it's still annoying to use them. Yeah, and so the next bit is we just want to talk about how liquidity can flow seamlessly. So there's like 3 main ways of making liquidity flow. There's these shared ecosystem bridges. There's bridges between ecosystems, which is a very new up and coming thing. And then these mint burn tokens that essentially, like those pools of money, or in a similar way, you can send tokens between chains by burning them on one chain and minting them on another. Oh, we've lost Chad. I thought he froze up for a bit there. Okay, I'll just continue explaining it for now. So I'll give you a little bit of overview of how bridges currently work. So like when you want to bridge to say Optimism or Arbitrum or any layer 2, you actually lock your tokens in a smart contract on Ethereum itself. Basically then those tokens, like the Optimism sequencer checks that bridge, sees, hey, Tim locked some tokens, and then it creates like a artificial token on the Optimism chain that represents that same token that I locked away. So if I lock USDC, it gives me USDC on Optimism. But this USDC on Optimism has a different address and essentially is a different token. It's just backed one-to-one by the token in the bridge. And so people treat it as the same asset, even though really it is a totally different thing. Hey, back.
I thought I lost power, but actually my computer just died and won't reboot, so I'm on a different one.
Oh, weird. That timing.
Yes.
So I just talked about how bridges currently work.
Okay, cool.
Yeah. And so one of the biggest upgrades coming soon is this idea of like an ag layer, or a super chain, or the interop layer. There's a bunch of different names, but essentially what it means is that instead of every layer 2 having its own bridge, you can have one shared bridge between a bunch of layer 2s. And the reason that this is really cool is that when I now lock my token from Ethereum to say Polygon, the token itself is locked in this interop layer bridge instead of in the Polygon bridge. And the reason that this is beneficial is that the interop bridge does the normal check that I've locked the token, and it mints that token on Polygon for me, just like usual. But if I want to move that token between Polygon POS and the OKX chain, because they're both connected to the same shared bridge, I can basically just burn that token on Polygon, just like throw it into a certain smart contract that it's like locked, kind of like the liquidity, but you don't actually need a pool of liquidity. But that token gets burnt. And then the interop layer is like, okay, it's burnt now. The interop layer still has my original token from Ethereum, so it's still got that backing token. And so it can then remint this token on the OKX1 chain for me for free. And it can do this very quickly. So the idea is that these interop layers will have their own settlement and finalization. And so basically I can move this token. It'll take 10 to 20 seconds. It should be hopefully free. I'm not sure what the cost will be, but very cheap. And the biggest benefit is that we don't need anyone to lock up a whole bunch of tokens, and we don't need market makers to make this happen. This can just work through one bridge that handles this all automatically with smart contracts and very quickly, and you can move unlimited size. So if you have $10 million USDC on one of these chains, you can move it to any other chain. without worry there being like a liquidity or anything.
So this basically creates a coarser grain version of the problem, where there are larger ecosystems where everything interrupts quickly, but unless there's just one of them, we're still going to have this fragmentation, right?
Exactly. Yeah. So that's the big problem, is that so there's lots of these different solutions, and all of these ecosystems want to use their own solution. And so like Polygon wants everyone to sign up to the AG layer, Optimism wants everyone to connect to the superchain, and so on. And it would be great if all of them do that. And there is a possibility of some chains. I don't think this is in the presentation, but there is a possibility of a chain that does connect to all of these layers and then provides like interop between them. That would still need liquidity and things in its own pools. But yeah, that's kind of a problem.
Clarification on the last thing. When you talk about burning and minting these tokens, technically what actually happens?
Yeah, so essentially what will happen is on one chain, you'll send the token to a smart contract where that token is basically locked and burnt forever. Nobody can access it. So, for example, there's often a contract that's like many zeros and then DEAD at the end, like dead, which is like considered a burn address. I'm not sure exactly what that will be on Polygon or these layers, but basically you send the token there, and then there'll be some site or something where you can create a proof that you locked this or burnt these tokens away. This should be handled by their servers for you. And then this like ZK proof can be sent to the AG layer itself and says like, hey, in this block, I sent this token to the burn address, and then the AG layer can check that. It can look at the proof and be like, okay, you definitely burnt it. And then you'll be able to send a message saying, hey, please give me the same amount of tokens on this other chain. So you'll send that message to the AG layer. The AG layer will check that you burnt it, check that you like it's all correct, and then it'll basically create the token on the other chain in the same way that like layer 2s mint tokens whenever you bridge to them normally. So normally when you bridge to a layer 2, it checks that the token's locked and then mints the token on the layer 2 for you. It'll do essentially the same thing.
Okay, great. And the AG layer, superchain, etc. These are basically like product names created by the people in these ecosystems, right? So AG layer is the Polygon one. Is that right?
Yeah, exactly. Yeah. So AG layer is Polygon. The superchain is Optimism. There's a few that like the generic name is kind of an interop layer. ZK Sync has a very similar kind of layer as well. Arbitrum's doing something with layer 3s instead of this, but they may end up doing a shared bridge as well. But most ecosystems are working on this kind of like shared bridge concept, and they're different in slightly different ways. But the shared bridge is the main focus of this.
Right.
And so, yeah, these ecosystem bridges are great, but the main disadvantage is that they're only for one ecosystem. There is the risk of that they're a single point of failure for an entire ecosystem, though this is a similar risk to just like any native bridge to any layer 2, and they're quite simple and secure. It's not a very big risk. It's mostly just that. And then also you can't really just add this to an existing chain. Polygon is trying to do this with their POS chain at the moment, and I think Optimism will have to do it with a bunch of their chains in the future. I don't really know how that's going to work, but we'll see. But it's a lot easier
to add to an existing chain. Why is that hard?
The main reason is because the tokens on different chains have, or they're already locked in different bridges, and they're already minted on different chains with different addresses, and like.
Right, you can't just like arbitrarily decide you're going to mint more ETH on a chain without causing major disruption, right?
Yeah, so like if for example Base and Optimism connect to a new superchain, that superchain that will not have the same permission to mint tokens as their native bridges did, and so it'll have to mint tokens with different addresses. Maybe they could figure out how to make that work. In my mind, I feel like when they connect to the superchain, any assets that go through the superchain will have a different address. So you'll have like USDC, like 2 different types of USDC and 2 different types of die, and yeah, there'll be a lot of issues with that. They may do something where, so for example, USDC on base started off called USDBC or something, and then they moved over to USDC, and then everyone had to kind of like burn their old tokens to get mint the new USDC, and it was like this whole problem. And you can still sometimes see it on dexes where it has multiple different USDC types, but like eventually this can be solved. It just may be a painful kind of switching over experience for these chains. So then the next level after this is, once we have these kind of ecosystem chains, it is actually possible to make it so you can move between ecosystems, as long as the ecosystems trust each other's bridges. So like they don't have to like trust them as in trust that I don't know, they basically have to know that the other bridge is secure enough, like battle tested enough, and that the other team isn't going to like change the bridge in such a way that it could break things, or like there's no basic like upgrade path for that bridge. And the reason for this is that so you can create these bridges across ecosystems, but essentially it works in the same mint burn model of the ag layer, or of these ecosystem bridges, where you burn a token on one chain and mint on another, except instead of going within an ecosystem, you go via Ethereum. And so in one ecosystem, you burn a token, and then that eventually settles down to Ethereum, and there's the data and stuff is stored on Ethereum that you burnt that token. And then the other ecosystem is actually able to, you can create a proof that you burnt it and send it to the other ecosystem. The other ecosystem can read Ethereum and see that, okay, you burnt this in this block. It's settled on Ethereum. I trust that. I'm going to give you that same token in this ecosystem.
Yeah, and by Ethereum, you mean the L1, like the base layer.
Oh, yeah, like the layer one, yeah. Because all of these chains settle down to Ethereum. They basically write all their data and a proof of what happened to Ethereum. And so they can actually check what happened on other chains between each other. And you can create proofs of what happened on one chain, present it to another chain. You can check Ethereum and check that the proof is correct, and so on. And the chains do have to coordinate with each other a bit, because, like, for example, USDC on all of these chains has different addresses. And so they need to have some coordination to say, like, okay, if I burn USDC in the superchain ecosystem, then move it to the ag layer ecosystem, then it needs to know what token is the equivalent token, essentially. Like, it needs to know, okay, these both like correspond to the same token. They need to create like these lists of tokens, or I guess they could use the token address on the layer one to figure out what should be minted, basically. They'd probably have like allow lists of what tokens are allowed to be minted and so on, or not on different chains. But like this requires a bit of collaboration between them.
Yeah, it also means like for arbitrary ERC20s, you don't really have a solution here, right?
Yeah, so they can do it for any ERC20, as long as it was. The harder bit is that it kind of has to be created on Ethereum, the ERC20. It'll be harder to move ERC20s that were created on a specific L2. Mm-hmm. That's what you mean. Yeah.
Yeah. Well, I was also just thinking about allow lists and coordination. When the list of 20s is practically infinite, then you can't.
Yeah, that's true. Yeah. So it's likely that there will only be like most of the major tokens will be supported, and then if you want to move less major tokens between chains, you might have to like swap it for a major token first, bridge it across, and then swap it back on the other side, or something like that. But yeah, we'll see how that plays out. And so this is slow because it relies on Ethereum finalization, but it does skip the layer one gas fee, which is very beneficial, especially in the future. I assume gas fees are going to be very high, and like, because you can always do this even currently by just withdrawing your tokens from one chain to Ethereum and then sending them to the other chain. The main problem is just the Ethereum gas fees. You don't want to have to keep paying that all the time. So this solves that problem at least. And so this could be improved even more if using Cosmos IBC. And so IBC is a protocol that Cosmos uses. So when you want to move tokens from one chain to another, it essentially, you lock them on one chain, and then a message gets sent to another chain saying, hey, they're locked. You can mint them on here. That chain mints the token for you. The downside of IBC is that it requires finalization and finalization means that like past this point, there is no way that transactions can be changed. So, on Ethereum, there is transactions happening all the time, and they can actually be what's called reorged, where like you do a transaction, and a few blocks later that block is skipped over, for example, and your transaction is lost, basically. Mm-hmm. And the problem with reorgs is that I can send money from one chain to another. That first send gets reorged and never happened. Now I have money in two places at the same time. Basically a double spend problem. And so IBC relies on finalization for these things to happen, because otherwise you have tokens in two places at the same time. And so what that means is the AG layer itself needs some kind of like validators and finalization for this to happen, for this IBC connection to happen. But what this means though is that if I want to send money from, say, the AG layer to Optimism, I can burn it on the AG layer, and then instead of minting it on another AG layer connected chain, it sends the message, it finalizes, which takes 10 to 20 seconds. It sends that message to the Optimism superchain. The superchain gets this message saying, hey, this guy burnt it on the AG layer. I'm going to mint it for him. And you can basically get like cross ecosystem transfers in like 30 seconds. And this is a lot faster than going via Ethereum, settling on Ethereum.
Is anyone working on this using IBC to do cross ecosystem bridges?
Yeah, so there's someone called Polymer that's doing it, and there's also someone called Union Build as well. That is, they're both working on IBC systems on Ethereum, and yeah, Union Build has a blog post about connecting the AG layer with IBC to other chains, and this is to connecting to Cosmos chains, but eventually you can connect AG layers together in the same way. It's be really cool. Okay. And so these moving between ecosystems, so tokens can move freely, the same way they can move within an ecosystem. But the main risk is that if one bridge is compromised, so for example, if an ecosystem has some exploit where you can pretend that you burnt 1 million tokens, that would be really bad, because then you can pretend you minted them, pretend you burnt them, send a message to another chain, mint unlimited amounts of that token, destroys the value of that token. So ecosystems need to be really sure that they have good like proofs of what happened, and that like their systems are secure. And so a lot of this will probably require ZK proofs, but not only that, but like multiple ZK proving systems. So in the future, most layer 2s want to have like, say, 2 different ZK proofs that prove that everything they've done is correct. And then if both those ZK proofs agree, then you can do these things, and that just makes sure that even if there is a flaw in the ZK proving algorithm, you can't break everything, because that would be very bad.
So when you talk about the 2 different ZK proofs, do you mean one on each side, or is this like a check and balance kind of idea?
Check and balance is that, yeah, basically because there's all these different kind of proving systems for ZK proofs, and all different ways of doing it. The idea is that, so there's this, for layer 2s, there's these stages of security. There's like stage 0, 1, and 2, and most layer 2s are still at stage 0, Arbitrum's at stage 1. But to get to stage 2, the idea is that you have 2 different proving systems that prove what happened was correct. And the only way that the layer 2 can be interfered with or changed is if those proving systems disagree. And then it kind of engages a security council and things like that. And the idea is that like, even if we have a flaw, and it's kind of like with Ethereum having multiple clients, the idea is that even if one has a bug, it's okay, because the other clients won't have that exact same bug, and they can keep running the chain. And so this is why we want like a diversity of clients. We want a diversity of proving systems, things like that, to make sure that these things don't break.
Cool.
And so the last way of doing cross-chain liquidity is these mint burn tokens. And so they work fairly similarly to like the AG layer, except that instead of every token in the ecosystem being mint burn, it's like these special standards. And so these can be done without an AG layer or without this cross-chain bridges and things like that. They're a completely separate kind of tangentially related way of moving tokens. And so so there's USDC is the first to pioneer this, and basically you can actually move USDC between like 8 different chains using their CCTP system, and essentially it you can burn your USDC on one chain, and then Circle gets notice of that and then mints it for you on whatever other chain you want. And the reason that USDC could pioneer this is because it's a centralized token. They can always fix it if something goes wrong. Like if it breaks and there's a double spend or something, they have the power to freeze tokens. They have the power to take. I don't think they can take them away from people. They can freeze people's USDC, and they control the backing asset. And so if it goes missing somehow, they can like just create more for you, things like that.
The CCTP is cross-chain transfer protocol, right?
Yeah, cross-chain transfer. Yeah, and that's pioneered by Circle, who created USDC. And so then there's these other standards like XERC20 and OmniChain, and they're essentially making it that any ERC20 can adopt these. And it's basically the same as the ERC20, except that you can now burn it on one chain, send a proof to another chain, and have that same token minted on the other chain using your burn proof. And so this can't just be like tacked onto existing tokens. Tokens do need to be redeployed with this. So the idea with like XERC20 is that they would deploy this, say, an XERC20 DAI token, and anybody can put their DAI into it and get a wrapped. It's like wrapping the token, wrapping a normal token in ERC20 into an XERC20, and then you can use that wrapped XERC20 to move it between any chains.
And when you say
and on the other side, you can unwrap it again if you want.
When you say deploy the token, you mean deploy the smart contract for the token on the chain?
Yeah, exactly, yeah. So yeah, we just need to deploy these XERC20 token contracts all over the different chains, and they can work together. These tokens, the movements would be the messages that, like, you've burnt the token and to mint it on another chain, that net messaging can be done by any kind of relayer. So like Layer 0 has a relayer, Chainlink has their CCIP relayer. That's the Chainlink cross-chain interoperability protocol. Synapse has something similar as well. They're basically just like messaging systems between chains, just to say that you've burnt it on one chain, you can mint it on the other. And so this mint burn is great because it avoids an ecosystem having to be an AG layer or having all these connections and stuff. It can just be done completely separately. It does require finality to Ethereum, so it does take a while. And the reason for that is that, like, you can't, chains don't necessarily trust each other. They don't trust each other to not reorg. But once they've written their data out to Ethereum, they can't reorg. And so it's safe to trust that the token was burnt correctly, essentially. So the advantages of this is tokens can move freely across any layer 2, and you can move any amount of tokens with no slippage. So just like all the other solutions. The disadvantages is chains have to be secure, so you can't have a chain that, like, if the chain can pretend that you minted, that you burnt a lot of tokens, that would break every other chain, because then you can mint unlimited tokens on every other chain.
Yeah, the weakest link basically compromises the entire system, right?
Exactly, yeah, exactly.
And I realize weakest link is an overloaded metaphor at this point, so accidentally.
The weakest chain.
Yes,
and the other disadvantage is wallets kind of have to support this. There could be websites that support this too, but like it would be nicer if wallets could figure that out. and you have to wait for finalization, so it takes 30 minutes or so. And so there is a way to speed this up, though. So there's this thing called a fast finality layer that EigenLayers that Near is working on with EigenLayer. And essentially, the idea is that instead of having to wait for your token burn to go all the way to Ethereum and take 30 minutes or so and be finalized on Ethereum, instead, that token burn message can be sent to Near, into the Near fast finality layer instead. And as long as both the layer 2 chains are connected to this fast finality layer and trust it, then you can burn the token, wait for the fast finality layer to finalize in 10 seconds or so, and then mint it on the other layer 2 in 10 seconds. Now, it'll make everything a lot faster. The main risk of this is like what happens if the fast finality layer says something happened, but then there is actually a reorg afterwards, and the same thing doesn't happen on Ethereum. You can get all kinds of issues. So that has to be worked out. And the idea is that like the fast finality layer is secured by economic security, so that that if that happens, validators get slashed. We hear that so validators could get slashed if that happens. But then the problem is that the validator wasn't the one that did the bad thing. The validator was just validating this Near fast finality layer. Someone else did something malicious via it. They get punished, but the malicious person gets away with it, essentially.
So the incentives are kind of screwed up in that case, right?
Yeah, exactly.
How makes sense then?
Yeah, and we talked about this previously, that really like the slashing is kind of an incentive for the validator to make sure that that cannot happen and make sure that things are secure and that the layer 2s are honest, or at least are not broken, or have no way of like malicious actors taking them over. And then this can be useful for making things faster, but yeah, it is risky. Do you have any questions about any of those before we go into the next bit?
I don't think so. I think you've covered it quite well.
Cool. And so now I want to talk about a future wallet experience. So like once these things are implemented, like how can the UI be even better? How can we make the wallet like solving the original problem that we had? And so there's a bunch of different ways that wallets are improving. The first is sharing gas between chains, so you don't need Ethereum tokens all over the place. The second is apps. Once fees get so cheap that they are getting now, apps can actually cover the gas fees for you. In the same way that Web2 apps cover all your fees for you, cover your server costs, and pay for it in other ways. The third is like how apps and wallets can interact better together. And then the fourth way is intents, which can be a whole topic on itself. So the first thing is, if you go back to my original thing, my original picture here, you notice I have Ethereum on 4 different chains in that picture.
Mm-hmm.
And that is not something that we should have in the future. Instead, we now have these ERC 4337 smart wallets, they're called. And essentially it's like a smart contract wallet. And what these allow is they allow for paymasters, for someone else to basically pay your gas costs on your behalf. And so rather than you having to have Ethereum on every chain, you can send this paymaster tokens on one chain. Even non-Ethereum, you could send them USDC or something to pay for your gas for you. And then they just have a gas balance. And then you can make transactions on any chain with these wallets, and the paymaster will just pay for you. And so you don't have to be bridging little bits of gas all around all over the place.
And with this paymaster thing, you could fund it yourself, or the dApps or protocols could pre-fund it for you as well, right?
Yeah, exactly. Yeah, so you could load it up, or maybe you use some wallet that has ads in it, and then the ads cover the cost of gas and something like that. Like, yeah, plenty of ways to do this in the future. In the same way, like Web2 covers your server costs. You don't have to pay like the AWS fees when you use Facebook. They figure that out themselves. We can do that in the future. So there's 2 wallets that are doing this already, called Avocado and Ambia. I think there's a few more on the way. And yeah, both of these, you can preload a gas balance, and then you can use that gas balance across all chains. And so, and then there's this thing called Bungee Refuel that gives you that for now. If you have problems with gas on one chain, you can use this to get a little bit of gas across many different chains at the same time, I think. And so that will make things nicer. And so the second one is two of my favorite apps. One is this one on the left is called Demo, and it's essentially like Venmo, but on chain, on Base, using USDC. And the second one is called Pay, and it's essentially the same thing, but with built-in privacy as well. And that's using USDC on Polygon underneath. And both of these apps are completely free. So you can put money into them, you send it to friends, your friend gets exactly the same amount of money that they requested. Just like Venmo, like when you use Venmo, it's free, but they make money in other ways. So both of these apps, I think, make money in their onboarding and offboarding, and in the future they may have other ways. They may have ads or something in there.
By onboarding, offboarding, you mean on-ramp, like
on ramp, off ramp, to your bank. So they might charge like a 1% fee or something when you move money from your bank to it, or vice versa.
Yeah, that makes sense. EIP 4844. Briefly, what is that?
So this is the one. So this is the EIP that lowered all of the Ethereum Layer 2 gas fees by having the blobs. So on previously, before this EIP, using Base or Optimism cost between 10 cents and $1. Now it costs less than a cent to make a transaction. And like previously, like if it cost $1 for every transaction, Demo and Pay would probably go bankrupt pretty quickly if they had a few million users. But when it costs like 0.1 cents, then they can handle 1,000 transactions for the same cost, and they can handle 1,000 times as many users, which is, and so that is cheap enough finally that they can cover the costs for everyone.
Right. And then when you talk about these requiring Sybil protection, you're basically saying if someone could mass create a bunch of different wallets, you could just drive these apps out of business in the same way.
Exactly. Yeah. So you don't want a malicious person bankrupting you by sending millions of transactions between fake accounts. So there's these Sybil protection things. So WorldCoin is the orb that you scan your eyeball and you get a WorldCoin pass. Coinbase is also doing this, where if you have a Coinbase account, then you can get free transfers. I think they're doing this with USDC, where you can get free USDC transfers on Base if you have a Coinbase account. But otherwise, it costs the transaction fee. And that's how they stop Sybil attacks. And then there's Gitcoin Passport as well, which is really good. So the other problem with all of this is that when you go to use an app on a website, you and your tokens across all these different chains, the app usually only knows about the chain it's on. And so it will only check for tokens that you have on that chain it's on. And we want to fix this. So we want, when I go to Balancer and I go to put some money in a liquidity pool, I want to see every token on every chain that I can possibly put in this liquidity pool, or make a swap, or whatever. So this shouldn't really be solved at the app level. So apps should only really shouldn't have to know about the entire Ethereum ecosystem and check like 1,000 chains and so on, because like they're apps, they don't have to do that. And so this should really be solved at the wallet level. And so there's this EIP 2256, which seems to have stalled out, but I'm hoping that people pick it up soon. I've been talking to some people about it. And this IP is essentially a API where an app can ask a wallet, hey, what tokens do you have? And the wallet can just give like a JSON representation of like, here's every token I have and how much I have of it, and so on. And the app can use that to update its UI to say what the user can do based on their tokens.
And in that case, you mean literally the specific user's wallet, right? What that user has in the wallet,
Yeah, exactly. Yeah, so you connect to the website, and the app can connect, use this API to check all the tokens in your wallet and so on. And what wallets can do in the future is if I'm using a wallet and it knows that I have say I'm swapping USDC on Optimism, and it knows that I have USDC on Polygon that I can use. The wallet can tell the app, hey, I have USDC. The app can be like, okay, cool, you can use this USDC. And then as soon as I hit the swap button, my wallet in the background can bridge that USDC in the background and then use it in the transaction afterwards. So it can do like a just-in-time bridge of the assets before putting them in the app. And this would get the ideal experience of being able to use any token in any app automatically, and the wallet would just handle that for you. And so there's this company called Orb Labs as well that's working on this, and they're building like an SDK and stuff to allow for wallets and apps to talk better together and make this kind of whole cross-chain world happen a lot more smoothly. And so the last thing is intents. So intents are a whole different way of avoiding this problem. And essentially, it's rather than my wallet and apps figuring out how to work together and do all these transactions, I basically say I want to interact with an app. I put out an intent saying, hey, I'd like to make this action happen. Like I would like to make this swap, or I'd like to put money in this liquidity pool or something. And I say, hey, I can assign a message saying like, this is what I want. I want $1,000 put in this pool. I want exactly 5 tokens for that. And I put that out there, and then any kind of market maker or solver can figure out what I need done, make it happen for me, and then collect the money afterwards. And so usually I'd have to like lock up some funds beforehand to make this happen. So I'd lock up my funds, and then I put this intent out, and the solver figures out how to bridge the money, how to get it to the location, or it fronts the money for me, and it watches the network to figure out the exact conditions that I want and makes that thing happen.
So who is a solver? You've used that word a couple of times now, and I didn't ask.
Yeah, so a solver is kind of like a market maker. There's someone that kind of runs a bot. So like the terminology came from CowSwap, I believe. CowSwap is a way that you can swap any token for any other token. And instead of it being like Uniswap, where it's a set of smart contracts, instead it's an intent swapping system. So you put your intent out there, they send that to their whole network of solvers and say like, hey, who can like get this guy his token for the best price? All of these solvers figure out, they're like, oh, I can get Tim his token for $5. I can get his token for $4, and they all compete. And then CowSwap takes the winner and then does the trade with them and then gives me the result. And so then I get the best trade from the whole ecosystem. The solvers just kind of like an auction. They figure out how to get this for me from anywhere in Ethereum. And
so it's really just like this massive scale network of bots competing in an adversarial manner to try to provide the most efficient service for whatever it is you're trying to get done. I guess there would be different teams creating solvers that have different specialties that are better for that. I see.
Yeah, kind of like MEV searches and stuff like that, like all these bots out there. And teams would specialize in like exotic tokens, or they might specialize in connecting to centralized exchanges and things like that to get the best price from anywhere. And so this intent system is basically using solvers to make that happen. There's a lot of depth to it. There's this thing called the Cake Framework, which is a very great overview of the space. And then there's this thing called One Balance, both by Frontier Tech. And so Frontier Tech are on the, great, thanks for the link. They're on the bleeding edge of this system and also bringing a lot of people together to solve this and create the best kind of intent system with all these different layers of this cake stack all working together really nicely.
Cool. So the Cake Framework is like a pattern language for describing how chain abstraction could work, and then One Balance thing is their implementation.
Yeah, exactly. Yeah, and so they give a common shared language on all of this, and also describe all the trade-offs. So there is kind of like those like pick 2 out of 3, like triangle of trade-offs kind of thing in this intent system as well. They pop up everywhere, and so it's good to have an understanding of where all the trade-offs are, and yeah, so we can make the best solution.
Great. I guess you have you have answered the question I was about to ask you. What's next?
Yeah, so what's next? So I've created a Telegram group called Ethereum Fragmentation Solvers. This is more general news and information about that. There is also actually another group, and that is the Cake Framework Working Group that is also more technically minded, but a lot of people that are also solving this kind of issue. So I'm Tim J. Robinson on, go to the next thing. I'm on Tim J. Robinson on Twitter, Telegram, Farcaster, GitHub, basically everywhere. Happy to chat about any of this. So you can reach out to me. Happy to invite you to the Telegram group. And yeah, anybody that's interested, I'd love to hear your ideas. And we can work together to solve all these problems and make Ethereum awesome.
Thank you.